Combustion of carbon monoxide gas produces carbon dioxide gas. Let's write that equation. Carbon monoxide is CO, and the combustion is going to require oxygen gas. Oxygen is diatomic, and that's going to produce carbon dioxide, which is a gas. It's not going to produce water. It can't produce water because there's no hydrogen in the reactant. So this is your equation. Let's balance this. The carbons are balanced, oxygens are not. We're gonna have to add a, I'll just show our work. You can show your work and then check your answer. I'm gonna have to double the carbon because I know this has to be an even number of oxygens, because on the right side I can only multiply by 2's. I've got to also put a 2 there to balance out the carbons. Now on the reactant side there are 4 oxygens, and the product side there are also 4 oxygens. So this is balanced. 2, 2, 1, 2 are the coefficients. Now that we have a balanced equation, we can do our 3 steps to solve almost all stoichiometry problems. So number 1, the value given, we need to convert that into moles. If it's not in moles, you always want to convert that into moles. All right, and so if you recognize here by reading the passage, it's giving you information about carbon monoxide, and then it's asking you information about oxygen. All right, that's characteristic of stoichiometry problems. They're going to give you information about one substance and ask for you to find out information about another substance. Okay, in this case, oxygen. All right, so step 1. Let's turn, what was it, 3.86 liters of carbon monoxide. All right, so label your substances, and let's turn that into moles. Liters of carbon monoxide has to go in the denominator to cancel out. And moles is the desired unit, so we're going to put that on the other side. All right, 1 mole is equal to 22.4 liters of any gas at STP. All right, and all your problems for now are going to be at STP if it's a gas. All right, now later on we'll learn that temperature and pressure will change. I believe that's actually our next chapter, but for now everything's at STP. All right, so now step 2, this is where we're going to use our mole ratio to convert the substance to the desired substance. All right, so we're going to get rid of moles of carbon monoxide, and we want to end up with moles of the desired substance, which is oxygen. All right, so these coefficients can represent a lot of things, but in stoichiometry they most often represent moles, or you can interpret them as moles. All right, so for every 2 carbon monoxide molecules, see, we can interpret them as molecules as well, you need 1 molecule of oxygen. All right, but we're going to use these as moles. 2 moles of carbon monoxide to 1 mole of oxygen. That's a conversion factor. They're equivalent in this recipe, in this equation. All right, let's cancel out our units. And our final step, all right, if it's asking you for a unit other than moles, let's see, how many liters? All right, so of oxygen. We already have oxygen, so we're almost there. We just need to turn our moles into liters. All right, so step 3 is to convert to the desired unit. All right, so right now we have moles. We want to get rid of that and turn that into liters of that desired unit. All right, notice the units, the substance has to match here. All right, so the equivalence is 22.4 liters, and this is a gas. All right, it has to be gases. These only apply to gases. is equal to 1 mole of any gas. All right, so there we go. We've canceled all the units except for liters of oxygen. That's what the problem is asking us to solve for. All right, let's punch these numbers in, see if we get the same number. 3.86 divided by 22.4 divided by 2 times 22.4. All right, and maybe you see that these cancel out. And so all you had to do was 3.86 divided by 2. All right, but that's fine. I'm going to get the same answer anyway. All right, our final answer is going to be 1.93 liters of oxygen. All right, 3 sig figs, 1.93 liters of oxygen.